Hi folks, welcome to Trig Equations 4. As always, there are downloadable notes if you want to print them off and follow along with the presentation, as well as a downloadable worksheet for afterward. Just check the video description below for the links. Trig Equations 4 is about reciprocal ratios, so these cosecant, secant, and cotangent functions. And all they are the reciprocals of sine, cosine, and tangent respectively. So cosecant is defined as 1 over sine, secant is 1 over cosine, and cotangent is 1 over tangent. We took some time to develop the trig table for sine, cosine, and tangent, and now we're going to just expand it so that it includes cosecant, secant, and cotangent. And it's pretty straightforward. If we want cosecant, it's just 1 over sine theta. So I'm going to take every value from sine theta and flip it over. So think about that first one. That's 0 over 1. If I flip it over, I'll have 1 over 0. Now, are we allowed to do that? No, we can't divide by 0. That's going to be undefined. The next one, 1 over 2. Flip it over, we get 2. Next one, we have two forms. And you can see the easier one to flip over is going to be 1 over root 2. So we get root 2. Over here, we flip it over, we get 2 over root 3. And that rationalizes to 2 root 3 over 3. So that's two ways of writing the same thing. Finally, we have the number 1. Flip the number 1 over, take its reciprocal, and you still have 1. For the secant row, we could go and do 1 over cosine. But what would be even faster would be for us to write our cosecant line just backwards. So this is going to be cosecant x backward. Okay, let's check it out. It ended with a 1 for cosecant, so for secant, it'll start with a 1. And we just go through the line in reverse. 2 over root 3, which is the same as 2 root 3 over 3. Root 2, 2, and undefined. Again, we could take our tangent line and take its reciprocal for cotangent. Or we can just do the tangent backward. Okay, so tangent seems to end with undefined, so cotangent will start with it. This will be root 3. And this is just a quick way for us to get our values. It's not much of an explanation for where they came from. But the explanation for where they came from is that they're the reciprocals of sine, cosine, and tangent, respectively. Okay, and finally we have a 0 here. So now we've got the big table with all of the reciprocal ratios. Let's put them to use in some equations. Right over here we have secant x equals negative 2. And I'm actually going to end up doing this two different ways. But let's start with just our basic approach, which is to find theta ref. That means you ask, where is secant? Not negative 2, but just 2. Well, let's go to the table. Secant is 2 over here at 60 degrees or pi over 3. So that's our theta ref. Okay, now the ASTC. There's no secant in ASTC, but we do need to think. Secant is 1 over cosine. We need to know that definition. So it's going to be related to cosine. Wherever secant is negative, cosine is also negative. So we're really asking here, where is cosine negative? It's going to be negative in this quadrant and in this quadrant. Okay, because secant and cosine are related. Now let's go and sketch. So pi over 3, this isn't a great sketch. That should be a little taller. But it really doesn't matter how good our sketch is. Pi over 3 and pi over 3. We need to find the measures of those angles in standard position. So the very first one would be 180, or pi. minus the pi over 3. Pi minus pi over 3. Okay, and that would give us 2 pi over 3. Just convert to a common denominator. The next one would give us pi plus pi over 3. Or 4 pi over 3. And again, you don't have to use the x1, x2, but it just clarifies that we do have two solutions here. Okay, so we're doing the regular stuff that we would have done. We just had to find theta ref using one of these inverse, or not inverse, but reciprocal trig ratios. Okay, here's the other approach that you could have taken to this. If you didn't like dealing with secant x, you could just take the reciprocal of both sides. And here's what that's going to do. That means on the left we'd have 1 over secant x, and on the right we'd have negative 1/2. Well, 1 over secant x, that's cos x. The reciprocal of secant is going to be cosine, and vice versa. Now we're back to dealing with the primary trig ratios, which is what we've done in the past couple of videos. Okay, so if I were to do it this way, I go and find theta ref. That means where is cosine 1/2? It's happening at pi over 3. We use ASTC. And we say, where is cosine negative? Cosine's negative over there. We sketch our angles. And you can already see, these are going to give us the same answers. But if you're a little skittish about working with secant, you can always convert to one of these primary trig ratios. Okay? And from there, you're going to have the same final angles. 2 pi over 3 and 4 pi over 3. Okay? By the same method. Pi minus pi over 3 and pi plus pi over 3. That's how they work for exact solutions. Let's try one with an approximate solution. So when we deal with approximate solutions, we have to be aware that the calculator, unless you have something super fancy, does not have a secant, cosecant, or cotangent button. Mine just has sine, cosine, and tangent. That means you're going to have to convert to one of the primary trig ratios, sine, cosine, and tangent, before you can get your calculator's help. So in this one, we have solve cosecant x equals 7. Well, let's think about that. Cosecant x is 7. If I were to flip that upside down, I'd have 1 over cosecant x equals 1/7. Now, 1 over cosecant x. Cosecant is a buddy with sine. So 1 over cosecant is the same as sine x. At this point, we can get the calculator's help, but not before. Now we can go and find theta ref, which is going to be the inverse sine, or arc sine of 1/7. Okay, let's go and do that. And we're working in radians here. So I'll make sure my calculator's in radians. Yep. Inverse sine of 1/7 gives me 0.143 radians. So a pretty small angle. Next step, decide what quadrants we're in. And the whole thing looks a lot easier once it's written this way. So since sine is positive, we're in quadrants 1 or 2. I'm not sure exactly how big this is, but the main thing is that I draw it in the right quadrants. 0.143. And from there, you can see your first solution is just 0.143. Your second solution will be 180, or pi, minus 0.143. Okay, and you can probably guess what that's going to be, but let's go to the calculator. Pi minus 0.143 gives us 2.999, or roughly 3. X2 is going to be 3.00. So we needed, in this case, to convert it to the primary trig ratio. When we dealt with the exact solution in the first example, we had the choice. We could either deal with it as a secant and go to the big table, or we could convert it to cosine, to one of the primary trig ratios, and then use the little table. I kind of like putting them all in primary trig ratios, but it's up to you. In the next video, we're going to look at what happens when we do solutions that are beyond that first revolution. So I hope to see you for it.